Hey guys, Miss Eck. This is 6-4 using inverse functions. So when you hear the word inverse, what it means is it changes the input and the output, so it switches them. So if I had an original equation, it doesn't matter what it is, it could be y equals, I don't know, 3x plus 2. Whatever we input a number for x, some number, and we take it times 3 and then we add 2 and then it spits out a y. So we input all these x's and it pops out a y value. But what inverse does is it's changing the x and the y values. So if the original equation you plugged in a 0 and you spit out a 6, then you look at the inverse. If you plugged in a 6 and it spit out a 0, that would make it an inverse. So it's technically switching where the x and the y are. The other meaning behind inverse is it's a reflection across this main diagonal line. So if I did the original equation, and I plotted a point here, then the inverse would be flipped that point across the red line. So it's a reflection. But that's not super important, but what's important to you is finding that inverse. How do we find the inverse? So there's 2 steps to do that. Step 1, switch x and y's spot. Step 2, after we switch, we're going to solve for y. So it's a fairly simple process. So if I said the original equation was y equals 4x plus 2, and I asked you to find the inverse of this equation. So the first thing we're going to do is switch the x and the y spot. So instead of y equals, it says x equals. And instead of 4x, it says 4y. Okay, so that's just step 1. Now step 2 would actually be to solve it, get y by itself. So in order to get y by itself, x is already by itself, but y by itself means we need to undo the plus 2, right? We're undoing things. That means we do reverse order of operations. So we're going to work back here. It's undoing all addition and subtraction before we get multiplication and division. So we're going to subtract 2 from both sides. However, I can't take x minus 2, so I write it horizontally. And then the last step to get y by itself would be to divide by that 4. Now, don't forget that because we're dividing the right side by 4, we need to divide all of the left side by 4, so both items. So our inverse, now that y is by itself, we can leave it as x minus 2 divided by 4. We don't just want to divide the 2 by 4. We don't want to call this 1/2 because what you did there was only divide the 2 by 4. You didn't divide the x by 4. So if you truly do want to divide by 4, another way that you could write this is x divided by 4 minus 2 divided by 4, which would be 1/2. So either of those 2 options would work, but I like this one because it saves time and saves steps. So let's look at one where it's got a power in it. So this y and this x were both to the first power. But looking at this function, this x is to the 5th power. So same steps apply. We're going to switch the x and the y. Okay, well I see an x, but I don't see a y. Remember, f of x is just a fancy looking y here. So if this is my y and this is my x, I'm going to switch the order in which they're written. So now that's y to the 5th. So that was step 1, switch the x and the y. Step 2 is solve. Reverse order of operations. So we want to undo any subtraction or addition, which we have here. So we're going to subtract 5 to undo the add 5. We're going to do that on both sides of the equal sign. Okay, here's our equal sign for reference. X minus 5 on the left, and 3/4 y to the 5th on the right. So we undid addition and subtraction. Now we want to undo any multiplication or division. So I have this y, and it's guarded by two items. It's being times by 3/4, and it's being raised to a power or an exponent of 5. So we need to get rid of multiplication before we get rid of this exponent. So one way to undo times by 3/4 is to times by its reciprocal. So we're going to actually multiply by 4/3 to cancel out the 4 and 3. Now our y to the 5th is isolated. However, if I do it to one side, I have to do it to the other. So remember the problem before, we divided both items by 4, the x and the 2. And same thing here, I need to multiply both items by my 4/3. So the easy way to do that is to write it in parentheses to show that I'm multiplying everything in parentheses by the reciprocal of 4/3. You can leave it like that. That's fine with me. That shows me exactly what you did. But however, we're not done yet. Okay, so we really do need to get y by itself, and this power of 5 is bothering it. So do you remember what undoes a power? So say we had x squared, what undid that was a square root, right? A root with a 2. Index cancels a power of 2. So if we're going to cancel a power of 5, we need a root with an index of 5. We need a 5th root. So a 5th root and a 5th power are going to allow that y by itself. Okay, so match the root with the power and they cancel. So I need to 5th root the entire left side, and truly none of those are perfect 5th roots. So the best that we can write this as the 5th root of 4/3 and in parentheses x minus 5. So let's just not overcomplicate it. Let's just box in our answer because that's as simple as it gets. All right, so I'd like you to try these two problems. I'm not going to work it out for you. So when you try these two problems, tomorrow on your homework, you're going to have to enter in their answers. So please work on them. Use the two examples that I gave you. Find the inverse. Remember, there are 2 steps in doing that. Switch the x and the y, and then just get y by itself. Good luck.